So thanks for joining this session. It's an extended session than what was originally planned. The session is going to be two parts. So this is the OTT state of play. The first 60 minutes we have is a panel discussion with representatives from Netflix, Hulu, and Amazon Video. So that'll be 60 minutes. And then after that, we'll be joined on stage with Alex Dunlap, who's a general manager of AWS Elemental. He'll be talking about the new media services that we launched early this morning from AWS Elemental. So just to explain who I am, my name's Lee Atkinson. I'm a solutions architect for AWS. I work in the media entertainment practice within the UK and Ireland team based in London. So joining us on the stage, we have Vinod Viswanathan, Director of Media Cloud Engineering at Netflix, Robert Post, VP of Engineering for Hulu, and then Winston on the far left there, on my side, far right for you, the Global Head of Digital Video Playback and Delivery for Amazon Video. So welcome, everyone. Welcome.
Thank you.
So just to start off, could you just explain your roles in your respective organizations and how you see innovation, especially around the OTT market? Vinod, if you start.
Yeah. I'm Vinod Viswanathan. I'm Director of Media Cloud Engineering at Netflix. So what my team does is provide storage and compute infrastructure for all of media processing for Netflix. That includes... Can you hear me now? Hello? Is it better now? Yeah, I'm Vinod Viswanathan. I am Director of Media Cloud Engineering at Netflix. And my team is primarily responsible for providing storage and compute infrastructure for all of media processing for Netflix, which includes images, streams for our website, and also the innovation platform to support streaming innovations and also provide the scale to keep the Netflix catalog current with all our innovation.
Great. Hi, I'm Robert Post, VP of Engineering at Hulu. My teams are responsible for the end-to-end technology for our content and advertising businesses. I've been part of Hulu for a long time. I was there before Hulu was even called Hulu, so that's about 10 years running. And I can't think of a more exciting time to be part of Hulu than now. In addition to our thriving VOD business, we just recently launched a live product. So as a consumer, you'll have access to 50 live TV streams, including your local affiliates, national channels, regional sports networks, and whatnot. In addition, I manage our ad platform team. We've built our own ad server at Hulu. We deliver personalized ad experiences throughout all of our different products. And prior to Hulu, I was at Microsoft. I was working on the Windows Server team, responsible for distributed file systems, and shipped several versions of Windows Server there. So I'm happy to be here today, tell you a little bit about what we learned, and talk a little bit about the future. Thank you.
My name is Winston, and within Amazon Video, I head up a product tech organization. And our group is responsible for broadly 3 different areas. One is Amazon Video Security, and the other one is Amazon Video Operations Excellence. The third group is the core video playback and video delivery. In simple terms, this group is responsible for all the aspects of the media, which is video, audio, captions, end-to-end, for both live and video on demand globally. So if you take that to a level deeper, that is from both live and VOD perspective, it is the signal acquisition from a live perspective, and for VOD, it's all the content encoding, content packaging, encryption, rights management, policy enforcement, as well as the delivery of the video from our content origin to our customer's location, wherever they are globally. So we build systems for quality of service measurement. We build systems for playback optimization. And again, there's a lot of innovation going on in the space to continually innovate to provide the best experience for our customers, irrespective of their network conditions. As you know, the internet is pretty congested and has got its own problems, but as a service provider, we have to provide solutions that overcome those and provide a seamless experience for our customers. And then we build our own video players as well that go on the different platforms. So we have player teams that build players for the iOS platform, the Android platform, and the range of living room devices and the web platform as well. In terms of innovation, a lot of innovation going on. I would concur with Rob. I think it's a very interesting time in the transition, in the evolution of the entertainment industry, how consumers are consuming media, and how consumers are watching content through different devices, and the watching patterns are also changing in the industry. I think being in the crux of that and being able to innovate both for VOD as well as live, as you probably know, Amazon Video is streaming Thursday Night Football in our service, and we did ATP, which is a tennis tournament as well recently. And so a lot of innovation going on across the board, and very exciting, and very excited to be here.
Thank you. Thanks, everyone. So the first question, I'll start with Rob. There's many different specifications around metadata, structure, content, the file transfer of those between yourselves and partners, between many different types of codecs for video and audio, the packaging, the containers and protocols and delivery. And we seem to always have many different competing standards. How do you approach different standards, choose the standard that's appropriate for you, and how do you think the future is with specifications?
Sure, that's a great question. First and foremost, as an aggregator and also a distributor of content, we like standards. We want to be able to do things in one way on every kind of interface that we have throughout the value chain. Maybe let's break the question down a little bit in regards to ingestion, then maybe encoding, and then maybe delivery. On the ingestion side, we have a pretty large VOD business. We take video basically in several preferred formats, but honestly, this is an area that I can control. I have a team to work on this, and we'll often take things from content programmers that they have sitting on their digital shelves, just to make the integration with them a little bit easier. But we do have preferred formats there, ProRes, MPEG. On the live side, we take a transport stream coming directly out of some head end, either from the programmer or even an affiliate station. On the metadata side, we use a proprietary format, actually, for our metadata. Remember when we started this 10 years ago, there weren't a lot of standards available at that time. We have also adopted the Cable Lab spec moving forward on the VOD. For live, we take out-of-band SCSI 224 metadata. That is the ESNI spec. And we've seen here that there is a lot of different interpretations of that spec, and it's pretty early. But from the integrations that we've done with programmers today, we feel like this is something that can help us with the audience definition, help us with all the metadata that we need to know about what's coming on channels in the future, as well as what we're playing right now. So we believe that this is probably the spec moving forward, but we think that there needs to be a little bit more lockdown on some of the interpretation of the spec itself. On the encoding side, we're on the VOD world, we're a FFmpeg shop. We've had a lot of experience and a lot of team members on the team kind of digging in on FFmpeg quite a bit. We've made a lot of modifications and sent some of that upstream as well. We do everything in H.264, although we do have a lot of HEVC coming onto the platform soon. We have a pretty extensive evaluation platform for how we test different protocol or different codecs. Here we're looking at both the subjective and the objective video quality and kind of comparing that to our library. Our library is a little bit different than all other libraries, and we want to make sure that we're choosing the right codec for what we're making available to our users. On the delivery side, we were early adopter of MPEG-Dash. We believe that this is the best container format for ourselves as a distributor, CDNs, and also the consumer electronic folks. So we'd like to see more adoption there across the board, but of course we do also support other delivery formats like HLS.
Winston?
Yeah, from an Amazon Video perspective, obviously we have a very large number of partners, over 1,000 partners that we integrate with for acquiring content for the different businesses that we support. Obviously we have our core Prime Video business, we have our transactional business, and we also have Amazon channels. So in terms of the number of partners that we integrate with globally, we obviously have a clear specification for onboarding content. And historically, we've used our own proprietary format, similar to what Rob mentioned, because there were not many standards out there. In the last, more recently, we have adopted the Movie Labs Media Core, Media Manifest Core, and Media Entertainment Core standards for the ingestion of metadata as well as the asset definitions. We also use the Movie Labs EMA avails format for all the avails definition as well. And we see us adopting that more, working with our partners. And our goal at the end of the day is to reduce friction with our partners. And I think this is not a space that there's a lot of opportunity for innovation. I think it's an opportunity for simplification. It's an opportunity to reduce friction so that we can onboard content in a pretty seamless manner, thereby increasing selection that we can make available for our customers. And we also support the Cable Labs format because there are partners that only support those standards. When it comes to the actual media itself, obviously we support a range of formats for the video and the audio and the captions. And here again, our goal is to reduce friction with our partners. And therefore, the tech teams have a whole range of formats to support. But at the end of the day, from an integration perspective, it becomes easier for our partners to interface to submit their content to us. Live is a totally different game. Apart from the format itself, where we acquire the content, how we acquire the content, over satellite, over fiber, where do we cross-connect, how do we ensure that we get a reliable stream 24/7, or if it's for a game, for the period of the game. And that comes in with a lot of architectural definition and engineering efforts, which unfortunately at this point is very fragmented. And there's a lot of upfront effort that needs to go in to be able to define that integration and onboard a specific partner to our platform. In terms of the delivery formats, very similar to what Rob said, Dash. We are an early adopter of Dash as well. We are migrating most of our streams to Dash. And obviously, we use HLS for the Apple devices. And I think there's a lot of innovation that goes on from an encode perspective, and how do we optimize the visual quality? How do we ensure we squeeze more bits? Because as we go into countries like where there is bandwidth constraints, we need to ensure that our encodes are very efficient, still providing a good visual quality for our customers. And the packaging formats are obviously different, and we use Dash and HLS pretty heavily.
Okay, thanks. And Vinod?
So Netflix has a very good input specification because we want the best quality assets, the original assets in terms of the aspect ratio as well as the frame rates and so on. So we have the best quality assets, and we support a few different formats like what Vincent was saying for all of these assets. And our specifications call out very clearly how to deliver to a WAD service, and we want the original artistic intent to be reflected in the source materials. And also, our tight input specification makes it very little more easier for us to do the processing because we do all our encoding on commodity compute on EZ2, and storage is S3. And having good input specification helps us because our processing pipeline to do the encoding and deliver the output is kind of staged, where the first stage is a deep inspection of the assets coming in. So we kind of use our specifications. We have built inspections to make sure that the quality of the input meets what we expect. And if we find issues with the source, we just reject those source so that it doesn't go into the encoding process. So the encoding process is little more deterministic in that sense because all the bad inputs get rejected. And we would expect our vendors to redeliver those sources, and that makes their systems much more stronger as they deliver more and more content to Netflix. So in terms of on the source side, we like IMF as a specification because one of the things that we have seen as an aggregator is the difficulty in acquiring these assets because there is a lot of versions out there for different purposes, broadcast, airline, where they have been, secondary assets have been confirmed with them. So we have seen the issue, what we call as versionitis, where it's sometimes difficult to get the right source material coming in. So we are looking at IMF as a good way for the inputs to be delivered or even archived, because it makes it easier that you have a uber set of assets, and then any versions that you do at that point in time, you are just passing the instructions to make up the asset and not really delivering, which means if you have 5 or 6 versions, you are not having 6 copies of the assets and making your vault very difficult, but you're having one uber set of assets and you have 6 instructions to make up these different versions. So we are taking deliveries of 4K and UHD content through IMF, and we also favor IMF for our HD and 2K deliveries, and we also take ProRes and MPEG as well. And part of what our inspections also make sure is that we can do chunk parallel processing, because we do all our encoding in software, and we bring the scale because we can do the processing in parallel, which means we can chunk the source into smaller chunks, a group of frames or a few seconds of video, and we can encode all the formats that we want and all the bit rates and all the chunks in parallel, and then assemble the inputs together. That's how our pipeline works. So the inspections are also running in the same chunk model. So irrespective of the size of the or the runtime of the video, we would be able to inspect them kind of in constant time. And similarly, our encodes are also on constant time. And we do all our encoding prior, we DRM the content, and then we package them, and we have a few different codecs because Netflix supports a wide variety of devices, and we want an efficient encode for each one of those device or device categories. So we do what is needed to make sure that we can get the device reach. So we support a few codecs, and we continue to see that. In terms of innovation, what we are seeing is the new codecs which are coming up, which are much more efficient when it compressing 4K, or who knows what's going to come later. That's one. And within Netflix, we are doing a lot of innovation, like the per title ladders, where we look at the complexity of the content or even portions of the content to figure out what is the right amount of bits that we have to provide. And a lot of our innovation is going to be in much driving efficiency and making sure we are giving the best possible quality to the customer, irrespective of the environment they are in, the devices they are in, and the bandwidth constraints that they are facing at this time.
Okay, thank you. On to the next question. Traditional TV broadcasters tend to be focused on a particular region, whether that's a whole country or whether it's, as in the US, you have affiliates in small regions across the country. Your services may go over these different regions. What are the technical challenges of both working across multiple regions, but also you also receive content from different partners across the world? What are the challenges of receiving content from these different partners and performing services such as translation and subtitling for different languages as well? And I'll start with Winston.
Yeah, as of prior to December 2016, Amazon Video was primarily serving 5 countries. And as of December 2016, we've been serving our content. We have a service that's a global offering to our customers everywhere in the world. And obviously that comes with challenges, that comes with exciting opportunities as well for innovation, to be able to deliver content to customers literally across the globe. And it's been an interesting journey. And I want to just highlight 4 key areas where there are obviously many areas of challenges, but I want to highlight 4 areas. The first one obviously is what you already mentioned, right? It is you need to localize the content. If it's just one language, it's not going to be interesting for customers in different countries. So in Amazon Video, we have obviously multi-track audio. So we need to have the local audio languages, local audio as well. And we also have local language subtitles. And this in itself poses challenges in terms of how we receive the content for the different languages from our partners. Obviously, you may not receive everything at the same time, so your delivery processes would change. How we acquire content may have to be through different post houses or different partners, and this has to be done in a global scale, and yet focused on the regional requirements. And obviously your workflows and your operational processes will all have to be tuned to be able to adapt to this model. And we have built systems, we've built operational processes and procedures that actually help us to be able to scale to offer our service globally to our customers. So first one is localized languages in the form of audio and subtitles. The second one is policy management. When you offer content globally, obviously the policies that need to be enforced are actually local. You have rights issues. You have rights issues at the title level, and in some cases you might have rights issues, rights requirements at the audio track level or even subtitle level, because a certain audio track may be available in a certain country, but it may not be available in a few other countries. So your policy management system, your policy validation and enforcement systems need to be localized as well to be able to figure out exactly where a customer is coming from, what the appropriate policies are for that specific title, for that specific language, and being able to deliver the content to the customer in a seamless manner. The third challenge is around customer experience. When you have 40-odd languages or more languages with subtitles and audio and different policies to be enforced, your discovery and your search mechanisms need to be tuned in with how the different policies are enforced. Else it's going to be a very fragmented experience. It's going to be disruptive for customers. So we have focused a lot in terms of how do we ensure that we provide a seamless experience for our customers to discover content and consume content no matter where they are in the world. The fourth one is obviously delivery. And delivering this content globally is not easy. We live in a country here where the network conditions are pretty good for the most part. And as you go outside, as you go to different parts of the world, the network conditions are different. The bandwidth conditions are different. The network variability is different. And how customers pay for data is also different. And you need to take all this into account as you plan for the delivery model and what experiences do you want to provide in your players. So from day one, we have implemented bitrate switching heuristics and delivery algorithms that are tuned for specific countries, tuned for different network conditions. And this is where machine learning and algorithm development are critical. As you look at different network conditions, we have a volume of data, but being able to look at the data and be able to tweak your experience and optimize the experience so that at the end of the day, the customer actually gets a very seamless, clean experience, irrespective of the network conditions. And so delivery is an interesting challenge to overcome with building the platform on AWS using the global S3 architecture. We have origins that are distributed across the globe. We work with multiple CDN partners, obviously including AWS CloudFront, which is our largest CDN partner, and being able to distribute the content with local caches and regionally distributed origins makes the overall distributed architecture pretty interesting and also provides the best experience for our customers.
Thank you. And Vinod?
Yeah, I think Winston pretty much nailed all the important ones. So one thing I want to call out is, let me start with the same thing. First is localization. That's very important. We don't like that subtitle assets or text assets are called secondary assets because in many ways they are the primary assets. If you are not speaking the language or you don't understand the original audio, subtitles become very important. So sourcing good subtitles and making sure they are rendered nice, they are readable, they are not on people's faces, they are not on other text, how to make sure that the subtitle experience itself is very good. And as a global company, we are just not looking at Latin languages, we have to look at Asian languages, bidirectional, you have like horizontal and vertical text to deal with how to effectively render them. And some of the languages have the accents, the rubies and boutons, and you need to make sure that you are handling the subtitles very well. So there is some work to be done on the specifications, TTML2 and IMSE2. They have to come along to make sure that there is a good way for global subtitles. That is something Netflix takes very seriously, and we even won a technical Emmy for the work we have done around subtitles because it is just it is just not text assets. There's a lot of work that needs to go in to make sure that the subtitle assets are sourced, processed, and presented in an ideal fashion, because it would make or break the viewing experience for a global product. And pretty much once then you have the audio, and you have to make sure that you have the dubs, like Winston said, they can come in different times. So for Netflix, even localization, one is a scale challenge, because when we want to localize in any language, we have to get a lot of content localized. And it is also for us a latency challenge, because we are doing shows like Chelsea Handler, which is the talk show, where we had to localize that content in 20 languages within 12 hours, because we like to launch titles day and date or the same day across the world. So for us, it's also the compressed time frames, because that's not something the industry is used to doing. So we have done a lot of innovation in building tools to help us through the process. We even have a product called Hermes, which is mostly a tool where people who are localization experts can come and they get tested, they get a score, and they get an ID, and we can track what is the talent pool available, and how can we even project the work that we need to do to get this localization done. So there's a lot of work still to be done to make the subtitling and text asset processing much more efficient globally. And the other part is streaming. Definitely, that's another place Netflix is investing in heavily in innovating, is to make sure we have efficient streams, because bits don't necessarily mean quality. So we have built our own quality scores called VMAP, which is what we are using to make sure that we are presenting the right encodes, and we have most efficient encodes, and we are providing a best quality for people. And the other part is also Netflix builds one product, so it is one service which has to look, behave, and operate in many different products, not just the streaming, just the discovery aspects of it. So those are very important and challenging. So any innovations or improvements we can do with image processing, because a lot of discovery on the Netflix site is images, so a lot of innovation is going to happen in that space as well. So we can have the product behave the same way across different regions. And then the content delivery, right? Netflix has a content delivery team, and we have done a lot of work to make sure that we can efficiently distribute our content globally and give the best possible streaming experience for the customer. And also, we build our product on Amazon. We run it on Amazon, so we use the Amazon's global capabilities for us to run our service also globally. So we have learned a lot in terms of how to run a global service, how to monitor, how to handle failover scenarios, the whole chaos engineering. So there's a lot of gone in to make this product a global product. So I think this question is pretty broad because it covers all aspects, right, from content to the product to the ingest, encoding. Across the board, you need to work on things to make a global product.
Okay, thank you. And Rob?
Yeah, I don't have too much else to add. I think that was a pretty good summary from everybody else here. But I will say, Hulu today is a US-based only service, so that kind of limits some of the exposure that we have to several of these problems. Although we do acquire a lot of content from overseas. We have very, very large Korean drama libraries as well as anime libraries. And here, our goal is always to try to acquire the content in the original audio that it was presented in or that it was created in, and then provide English language subtitles after that. In the anime world, we do have quite a bit of dubbing, but oftentimes when we were trying to kind of link the videos and kind of reuse the same video and switch the audio streams or even just align captions or subtitles, we found that a lot of the video was different. Small little edits, small little cuts here and there, which can actually throw off the viewing experience, and then it creates a huge problem. So in the cases where we do have dubbed language, we are ingesting it twice for the time being. Additionally, the other area where we focus on, at least like targeting to geo, is with the live product and the local affiliates. So if you're in New York, you should be watching the New York ABC feed. If you're in Los Angeles, you should be watching the Los Angeles CBS feed. And there's a lot of targeting that needs to happen in order to make that possible. There's also a lot of like audience definition that goes around that. I think this is an area where we're spending a lot of time to make sure that we're able to target the right affiliate to the right users. And if you're traveling, and should you be able to watch your home sports game if you're on the road? There's a whole bunch of like rights restriction stuff that goes into it, or the policy definition that Winston was talking about. And here, there's a lot of like innovation to be had in trying to ensure that you can obfuscate a lot of those challenges to the user, at least in the product. I think at the end of the day, you don't really care. You really just want to watch the shows that you love and the sports that you love. So we try to obfuscate most of that through the product. But the internet wasn't really designed with geography in mind when it was doling out IP addresses. So that makes it challenging to just rely solely on IP lookup. We do use that, but we do use a few other signals to help us with that. If you're a part of the live service, we do now ask for GPS enabled on mobile devices to help pinpoint your location a little bit better. But all in all, that's an area where there's still more to be done in order to make sure that we can really target to like an advertisement to you in a certain zip code. So there's a lot there to still continue to be done. But yeah.
Okay, thank you. Moving on, next question is, viewers have a high expectation of the audio and the video quality of the content that they watch. They expect the content to be resilient and no buffering, and also low latency. Latency can be two things. If we think about video on demand specifically, users expect the first time to the first frame to be as short as possible to watch that content and not rebuffer. For live content, you have this glass-to-glass latency. So when a goal is scored, for instance, they expect to be able to see the content quite soon after. They don't necessarily want to see the goal scored or hear the goal scored, be it on social media. How do you optimize the ingestion of content, the processing of content, and the delivery of that for these three important requirements from users? And the question is to Vinod.
For Netflix, of course, live doesn't apply right now, so we are mostly watch play. Play delay, or the start delay, and rebuffers are two very important things for us as part of the quality of experience metrics, right? And the other aspect of it is the quality of the streams that is being delivered to them. So whenever we do any innovation, we make sure that we don't sacrifice the QAE when we are doing improvements to on bitrate saving, so that what we are looking as a holistic experience is that you get great quality and as well as the great experience associated with that playback. So in terms of the what we do to achieve that is one is we make sure we don't allocate bits based on a standard ladder. Basically, we don't treat each content the same. We look at the complexity of the content and we make sure that we produce streams where each additional stream in the ladder is definitely bringing noticeable difference in quality. So the quality score that we have built, which is more of perceptual quality, and that has helped us drive that forward so that we are good stewards of the internet, that we are 1/3 of the peak internet traffic, and we want to make sure that the bits we provide offers meaningful quality for our customers. So, and we do a lot of innovation around in that area, and our next generation of encodes are going to be more about providing bits based on the complexity of the scenes or portions of the content. So these are much more efficient. And we do a lot of A/B tests in Netflix. So whenever we want to try out new things, we need to make sure that there is no quality of experience degradation across the board. So we do a lot of testing to make sure we cover devices, network conditions, that these streams are very, very efficient when they get out there.
Great. Rob?
Yeah, we know customer expectations are high, especially in the live world, but for VOD as well. We focus on it every day. Basically what we do is we collect telemetry on several key metrics from the players themselves. Every playback stream, we're getting feedback on several key metrics, including average bit rate, time to video playback failures, and also rebuffering ratio. So we're monitoring these in almost a near real time kind of a way and kind of inputting that back into our CDN selection algorithms to try to deliver the best possible experience for that customer at that time. It's easy to detect when we have problems with delivery because we'll see these metrics go out of their normal operating ranges, and we'll try to divert traffic to somewhere else in order to alleviate that for the customers. We've been finding, though, that this is a larger kind of surface area that we need to be optimizing on, and we've stood up some teams focusing on like MBR algorithm research. We've been focusing on our encoding, making sure that we are using our bits appropriately, as Vinod was saying, and working towards kind of creating the best quality with the least amount of bits. Other things that I can talk of specifically in the live world is there are definitely challenges here. We don't have a lot of redundancy in signal acquisition paths or encoding paths or even delivery right now, and that's something that we're working towards. There are still problems with the internet that kind of create a failure over here that can cascade to the user at the end, and having these redundant paths kind of make us a little bit more fault tolerant to those things, and we're working towards that now. Other big areas that we've seen, especially in the live world here, is around how do you monitor and how do you get alerts on these things. So when I said earlier that you have access to 50 channels as a viewer, what that means on the back end is I'm managing about 800 different channels because most of those are local affiliates. I can't really have a broadcast operations team watching 800 different channels just looking and waiting for something to happen. So we've been migrating towards a more of a nominally based alert detection system whereby if something's outside of the standard operating procedures or outside the standard operating metrics, our team will get alerted. We'll dig in and we'll do a full incident management of something that might be happening on one affiliate in Omaha, Nebraska. So this is an area where we're getting our PhD really fast in how to operate a live service, and this one area where I think we're going to see the most innovation in the short term.
Okay, thank you. Winston?
Yeah, let me talk about VOD first. When it comes to VOD, I think Vinod pointed out there are broadly three aspects from a QoS, or quality of service, that we look into actually very deeply and on a very, very frequent basis. One is obviously what we call as interrupts. Interrupt could be a rebuffer, a spinner, or a fatal error. Second one is the quality that's being delivered, the visual quality the customer is getting. Again, there are different levels of that. It's the perceived quality, it's the HD bits, and now we have 4K. Like how many 4K bits are we giving to a customer for a given bandwidth condition? And the third one is the time to first frame, or playback start time. And honestly, the customer doesn't care. Customer wants all three. And if you look at this, I view this like as a tripod, right? You can deliver SD quality to a customer and give them great time to first frame and a great reliable stream, but that's not what the customer wants. They want the best across all the three. And I think as engineers, as product owners, as service owners, it's our responsibility to continue to innovate along those three tracks and continue to improve the quality of our encodes, reduce the size of the fragments that we're delivering, improve our algorithms for figuring out the right fragments to download and serve to the customers, the buffer duration on the devices. And we also look at this as a closed loop system, right? We have the encode optimization and the encoding processes. You have the delivery optimization and the delivery systems for delivering the bits over the internet, through CDNs, through the CDN balancer algorithms, and a whole slew of other optimization systems that we have on the back end that are primarily taking the bits from the origin to the customer's device. So that's the back-end delivery systems. And the third part of the closed-loop system are the actual players, the video players that we build and implement on the devices. And we do look at these three as working in tandem. They're working in a closed-loop system, providing data back to each other. And I think in a good closed-loop system, providing data back and a feedback loop in place, you can optimize and continue to improve. And it is a continual improvement process. And the internet will continue to be more congested because there are more bits being streamed over the internet, and more customers are coming online. And I think we have an exciting, challenging future ahead to be able to optimize performance for our customers. When it comes to live, there is a fourth parameter we need to look at, which is the latency, or the broadcast latency. Customers do care about the first three that I mentioned, but they also care about how much am I behind the broadcast feed or the cable operator feed. And again, as engineers, we need to ensure that it is as close or better than the broadcast feed for us to provide the best experience to our customers. So I'll give a quick rundown of how we thought through this when we launched Thursday Night Football. And we've been doing live linear channels from December 2015. But earlier this year, not early this year, actually in Q3 this year, when we launched Thursday Night Football, when we got the deal back in Q1, there were broadly two areas, apart from building all the functionality for ad insertion and how do we acquire the signal and how do we deliver at scale. There were two broad tenets that we had in mind. One, reliability, and two was latency. And we felt that these two were super critical for us to provide a good sports experience for our customers. For sports, obviously, a second rebuffer is actually a second probably of the best play in the game that you missed, or you're behind, or you lost, or whatever it might be. So our goal was to provide a seamless, clean, clear experience for our customers when it came to reliability. So we had to work with our partners right from the truck at the venue. How do we get the signals? Do we have the right level of redundancy? Do we have the right architecture in place to be able to get the signal in a seamless manner, video, audio, captions, end-to-end to the customer's device? And Thursday Night Football is streamed globally, and we had customers from over 180 countries who stream our content. And so we had to ensure that reliability is very high. And reliability can be made very high with the right level of redundancy across the architecture. And again, this is not something that can be thought through towards the end of a project. You need to think through this right from the beginning, right from when you're defining the architecture, through the implementation, through delivery. Latency is the same way. You need to tweak every single second. And we had conversations about, should we do this? Should we invest in implementing a certain feature or a certain architecture change to get 2 seconds? And our answer was yes. It's going to be hard. It's going to be painful. But we had to squeeze every single second or every single time that we could get out of the entire workflow in order to be able to provide a low latency stream. I'm very pleased that we were able to provide a pretty low latency stream. And there's a lot of opportunity ahead. And it's quite exciting that we can do live streaming, OTT, over the internet to several devices with a pretty good quality. And there's a lot of opportunity ahead, a lot of innovation in progress, and I think it's exciting times ahead.
Okay, thank you. Next question is around artificial intelligence. So we've already mentioned artificial intelligence a little bit in the previous questions. It's quite common to think about artificial intelligence, its natural place, I guess, is within recommendations and things like that. But across the whole media supply chain, it can be used in many different areas. I just want to get your how you're using artificial intelligence in your organization, and where do you think that will where that's heading? And I'll start with Rob.
Sure. No, I really like this question because it is focused more on the media supply chain. I guess when you normally think about machine learning, you're thinking about what's happening in the reco world or personalization or even search in some cases. And the value prop of the media supply chain is to gather the base metadata in order for them to work on that. But we do that already. We collect the factual, the semantic, and the programming. Think of like maybe the scheduling information of what's on next for the entire catalog on the service, and we kind of organize that and kind of make that available to all those downstream partners. But if you take a step back and you think about it, every really interesting product experience that you can think of that connects a viewer with content that they love requires like great metadata. Not just like good metadata, you need like really, really good metadata in order to tie these two things together. So it may not be enough to know that Tom Hanks is in that movie. You might need to know exactly when he's coming into frame. And these are some of the things that are not accessible, or you don't have access to this type of metadata from the programmer or even from third-party data sources. So how do you get it, right? So you can either do it manually, which I don't think anybody thinks is a great idea, but it can work in a pinch, or you try to do it programmatically. So we have utilized some techniques in order to get some of this information programmatically, and one is around delivery of the ads. So in many cases, we're inserting and doing dynamic ad insertion directly into some VOD piece of content. We want to make sure that we're inserting it at the right point that doesn't interrupt the playback experience. So we have computer vision going through and looking at where are the chapter breaks, excuse me, where can I place an ad, where's the natural place to put an ad. And we don't even really want just second granularity there. We want frame accurate granularity of where these need to be. Another area is where the end credits start rolling. So the end credits roll, identify those end credits so you can have like a squeeze back experience and start to present more recommended content to the user at that time. Both of these are done with computer vision type solutions. Another is we have a face match detection algorithm, so we can find when Tom Hanks has that cameo on SNL. We know the exact time code of where he's coming into the frame. And we do then provide this data then to the downstream teams, and they integrate that into their reco and whatnot. We also made an investment in a company called the Video Genome Project through an acquisition, where we're trying to gather a lot more semantic data about content. How did it make you feel? Things like this that can also drive towards better recommendations. And we're piping that through our recommendation services now and kind of creating more of that base metadata for them to be able to work on. But here we're kind of trolling social networks, trying to find user sentiment of shows, and kind of collecting that and organizing that for those downstream teams.
Okay, thank you. Winston?
Yeah, I think Rob touched upon all the key aspects from a supply chain perspective. And I think this is an area where there is more innovation ahead. There is more opportunity ahead to be able to provide an innovative experience, an interesting experience for our customers. I think even if you look beyond the core metadata aspects, just from an encode perspective, I think there is a lot of opportunity there as well to be able to look at the encode and see what is the right profile, what is the right encode profiles that we can apply for a specific content or a specific scene. We know they already touched upon scene-based encoding, and there's a lot of machine learning aspects that we can employ to be able to identify aspects of the scene, aspects of the title, to be able to figure out the right profile for encoding that in turn is going to provide a better experience for our customers. And going further down the chain, you also have delivery optimization. There is a lot of data that we gather in terms of customers' quality of service metrics. We know exactly the bandwidth that they have. We know their network conditions. We know the actual experience they experienced the previous day, the previous session. And therefore, there's a lot of data that we have that in Amazon Video, we use the data to figure out what is the best heuristic treatment, what are the best CDN paths that we can provide for a customer in order to optimize their session experience so that they can have a seamless, clean experience. I mean, Amazon has invested very heavily in AI and ML. Amazon Video continues to invest, and recommendations and search is a key area as well. And as you mentioned, there's innovation and opportunities across the board to use ML and AI in order to provide a good experience for our customers.
Okay, thank you. Vinod?
Yeah, Netflix has been using ML a lot for recommendations, but coming to your specific question around what we can do with ML and computer vision and building algorithms for media, we can actually do quite a lot. So in Netflix, we look at media assets as big data because there is so much of information that is available in those assets, right? And we can see a lot of efficiencies, right from the media supply chain as well as something that is customer facing that can happen in all of those areas. So to the effect, what we have done is that we have kind of built a MapReduce-like platform for processing media assets, where we have made it very easy for our engineers to just focus on the algorithm that they want to do and not worry about any of the code that they have to write to run those algorithms at scale, where a Docker application is their, a Docker container is their application. They just figure out like, okay, I'm going to process, let's say, video files, I need scenes, or I need frames of video, and here is the map that I write for each one of those chunks, and here is what I collect, and they go about it. So we have onboarded a platform that makes it easier for our people to do a lot with ML and computer vision. So some of the applications that I can talk about, I think we have already discussed here. We have the N credits, basically detecting text on text, and making sure we can detect the start credits, the N credits. Even our quality assessment, the VMAP that I talked about, has a machine learning at its base, where it's trained with data that people have looked at, and it uses that to work out the quality of the streams. And we are also doing things which is time consuming to do, for example, detecting dead pixels, or in image processing, image clustering. A lot of those use cases can be done, and we feel that the platform that we have provided is just starting, and it's going to drive a lot of innovation within Netflix as to what we are doing. And this also requires a lot of compute. So the corresponding thing that companies have to figure out is that how they're going to provide that kind of compute at scale, right? Netflix, we are on EC2. So part of the work that my team had been doing in the last year and a half to roll out is also use all of the Netflix reserved capacity that is available, and services are scaled down at off-peak hours to drive that compute across the 3 regions to a lot of these processing. So in some sense, we have made it very easy for our engineers and algorithm specialists to be able to drive compute to whatever their use case, whether it could be R&D, this kind of scene-based encoding innovations, or it could be just codec comparisons that we have done in the past. For example, if somebody is wanting to do a research, getting up to 5 to 6 million compute hours is going to be very easy for them to do. So the associated problem that needs to be solved is also how to efficiently deliver a lot of compute. But in terms of the opportunities or the innovation that is available, a lot can be done using machine learning and computer vision, and it can meaningfully drive better experiences for customers, both in terms of streaming quality, the quality of the bit rates, recommendations as a service, and more deep metadata about the video that can be used to drive experience.
Okay, thank you. Before we start our last question, just a reminder that straight after this panel, we've got Alex Dunlap from AWS Elemental to talk about the new services that AWS Elemental launched earlier today. So please remain in your seats. It was not a change of session, it's a continuation of the session. So just to go on to the last question that we have, we've got a few minutes left. So you mentioned about multi-region. So often customers use multiple AWS regions typically for compliance reasons, or maybe to get the application as close to the end users as possible. Could you tell me a little bit about your strategy of running in across more than multiple AWS regions? And first, it goes to Winston.
Yeah, so let me talk briefly about what we did with Thursday Night Football. Again, going back to the point I mentioned earlier about being able to provide a highly reliable stream for our customers, the AWS multi-region architecture came into play for us. We clearly use that for the core encoding, packaging, the live encoding, live packaging services that you probably are aware of from AWS Elemental. And you probably heard the announcement earlier today about AWS Media Tailor Service, the new name, so I'm trying to learn the name, which we actually use for our Thursday Night Football architecture, which is used for inserting advertisements in our live stream, real time, and it's personalized and customized based on where you are and who you are. And it's integrating with third-party ad providers as well, including Amazon's own media group for delivering ads to our customers at scale. And obviously, ad stitching is complex, and ad stitching could reduce reliability, but we were able to provide a pretty reliable stream and pretty seamless stream for our customers, primarily with a highly distributed architecture, globally distributed, because our ads that we show in Japan are different than the ads that you would get in New York or the ads that you would get in Las Vegas for the same stream. And the ad insertion do happen in the globally distributed architecture in the different AWS regions using the AWS Media Tailor product. And having a distributed architecture definitely helps with providing a highly redundant and therefore a highly reliable stream. And we have used the multi-region architecture for our live encoders and packages as well. And I think just having redundancy itself doesn't really solve the problem. You need to have a clear, well-defined, and a clearly implemented architecture for failover. Just having redundancy on its own doesn't help. You need to be able to detect there is a problem. You need to have the right mechanism and the architecture and the system in place, end-to-end, including our players and the clients, to be able to fail over seamlessly with less interrupt the customers. I think that is what you need to design, and that's what we had to do right from day one, where we had to think through, okay, we're going to have in multiple regions, but what happens when a region goes down and a customer is connected to that? You need to think through that right from day one, and what is the signal back to the player so that the player can switch over in a pretty seamless manner, thereby providing, again, a clean experience, and the customer doesn't really lose the critical play in the game. And I would say the right redundant architecture using the multi-region capabilities in conjunction with the right failover mechanisms that you would implement in your end-to-end architecture can actually go a long way to provide a very clean, clear, reliable stream for our customers.
Okay, thank you. Vinod?
I think Winston pretty much touched upon it. Netflix, we are on Amazon, so our whole service runs on Amazon, so we use multi-region deployments. And it is not just availability, there is also failover. We do a lot of chaos engineering where we have the capability to direct traffic from one region to the other to make sure that we are immune to even region failing so that we can continue to maintain the level of service that we do. For the media processing perspective, what has happened is that we, in the last couple of years, have started using a lot of the compute that Netflix reserves globally because we reserve for peak capacity. And there is a lot of capacity that we reserve. But since our services are scaled down, there are troughs that are created during the day where there is less watching happening and more compute instances are available. So we have set up a system where we can use those compute instances to drive a lot of the innovation or the media encoding work that we have done. So in some sense that we are using Netflix's multi-region presence as, for the media encoding perspective, as a capacity boost so that we can go outside of our own reservations that we have done for media encoding and specifically go after all the instances that are available. And chaos engineering or failure engineering is a very integral part of how we do things at Netflix, and we have innovated a lot in making sure that we have a highly available service in the global service in the cloud.
Thank you, Rob.
Yeah, so for Hulu, we're not in the cloud completely for a lot of services. In fact, excuse me. We only started to really deploy services in the cloud for the live service. We manage multiple data centers in the US. We think of it from a perspective of redundancy and reliability. So the two major deployments that we do have are one around repackaging of the video streams in live before we deliver to the end user. And here we're repackaging for HLS and Dash, applying DRM and doing a few things there. But it is a single region right now. And this is where I spoke of earlier, that we're looking at kind of creating more redundancy there. We also appreciate diversity. So we use multi-CDNs, we use multiple encoding partners for the live stuff, we use multiple transit providers, signal acquisition paths. and we're exploring it from a redundancy plus diversity point of view. The other large major deployment that we have in AWS right now is for the browse stack, and that's basically everything that's presented to you as an end user. And we manage one AWS region right now, and we have the other traffic coming from our 2 data centers, and we have that behind all of it. So basically, like we're achieving the level of redundancy there by using all 3 of those sources, but we're really only in one region right now.
Okay, thank you. Rob, Winston, Vinod, thank you very much for your time today. It's been brilliant. Really enjoyed it. It's an honor on behalf of AWS and on behalf of myself to ask you these questions. For everyone, please congratulate and thank our 3 panelists. Still stay in your seats because we've got a second session. But to the panelists, thank you very much for today.
Thank you. Thank you.
So now for our second part of the session, I'm joined by Alex Dunlap. Previously, he was the general manager of Amazon CloudFront, our content delivery network. Recently, he moved over into the AWS Elemental team to be the general manager there. He's going to present an introduction to the new services that we launched beginning early today from AWS Elemental.
Thank you, Lee, and thank you to the panelists, and thank you all for coming. This is, oops, I'm going to just skip this. My name's Alex Dunlap. I'm the general manager for AWS Elemental. This is kind of a bonus session, so we have 30 minutes here. We announced last night 5 AWS Elemental media services. So what I'm going to do is talk a little bit about what those are. I really want specifically you all to leave with 3 things here today. The first thing, and most importantly, I guess, is I want you to understand the motivation. What were we thinking about when we were building these products? What customer problems were we looking to solve? What's the context for them? Why are these interesting for you as customers working with video? The second thing is we'll go through the solutions themselves. There's 5 of them, give you a taste for what they do at a high level. We won't go super deep. There are sessions later on during the presentation, during the conference where you can go deeper into what these products do. And then third, we'll go into some customer use cases. So we've had the opportunity to work with several AWS customers over the past several months in beta. So they've been trying the services. They've been using them for, in many cases, production applications and giving us feedback about what they think. And we've incorporated a lot of that thinking into our products. So with that, let's start with the motivation and kind of what we've built here. So as you saw today, AWS has a lot of customers in the media and entertainment space doing video. Video and media entertainment get used synonymously. And specifically, there are a lot of customers that are trying to do broadcast-grade video on AWS, and they're doing it successfully. Broadcast video, though, isn't just limited to media and entertainment customers. If you're doing corporate communications, if you're doing a big marketing event, like reInvent, gaming use cases, even surveillance use cases, a lot of these use cases have that same characteristics of broadcast grade. They need great video quality, they need great reliability, they need broadcast grade features. So, unfortunately though, in our view, the technology that is needed to make broadcast grade video experience happen is still more complex than what is needed. You can think of the pipeline running from a capture device, a camera, a production truck, a TV studio, what have you, all the way to the display. Customers need to worry about everything from ingest, how do I get data, video, how do I move data around, transcoding, how do I convert to the various file formats that are out there. Encoding, how do I manage compression in real time, 1 second of video in for every second of video that goes out. Origination, how do I package my video in order to reach multiple devices? Where do I store it from an origin perspective that connects to my CDN? We heard several, Winston talking about ad insertion, but creating monetization opportunities. These are the things that customers, if you talk to them, These are the things that they're spending their time on. These are problems that a customer trying to do broadcast-grade video anywhere is spending time, effort, energy in solving. But for the most part, they're not the things that when you ask these same customers, what makes your business special, these aren't the things that they mention. When you ask customers what makes your business special, they tend to talk about their content, they tend to talk about their customers' viewing experiences, they tend to say, I want to create great video, I want to create great content, I want to monetize it. I don't want to, it can be sports, it can be news, it can be entertainment, it can be, marketing or corporate communications. It's not the undifferentiated heavy lifting, managing the infrastructure needed to deliver broadcast-grade video experiences. So that, in a nutshell, is why we built AWS Media Services. We want anyone to be able to access the same broadcast-grade video infrastructure that powers many of the customers you heard today, without managing the underlying heavy lifting of video infrastructure. So for those of you who don't know Elemental, we started out as a software company. So I was working for Amazon. The company Elemental started in Portland around the same time that AWS got started as Amazon. But Elemental got started with the idea of building software-defined video. So at the time, the conventional wisdom was that if you wanted to do great video encoding, you use specialized hardware. And Elemental said, hey, we think that we can build software that will let our customers be more flexible, let our customers get better economics, let our customers get better video quality than is possible with hardware-based encoding. AWS acquired Elemental about 2 years ago, and we've been working since acquisition to create AWS services that remove all of that undifferentiated heavy lifting that I mentioned. So our vision is really that we can create video solutions that do three things. First, let customers hit the reliability levels that they get, or exceed the reliability levels that they expect for their customers. So we believe that the cloud and building solutions on AWS Media Services will help our customers create more reliable video experiences for their customers. Second, this is a space that moves very fast. I think you heard the rate from the panelists today. The rate of technical change in video is astronomical. Customers' expectations are really that they'll be able to watch anything on any device, anywhere, whenever they want. And we want to create infrastructure and services that allow our customers to be flexible, to be nimble, to adopt new technology in a way that we believe is only possible if you're building on the cloud. And then third, let customers focus. Really let customers spend their time on the things that make their business special, on their content and their viewer experiences, not on the undifferentiated heavy lifting of managing video infrastructure. So let's move into the second part of the presentation, talking a little bit about the services that we've built. Let's start with Elemental Media Convert. So there are 5 services. AWS Elemental Media Convert is our file-based video encoding solution. So this is a solution that lets you encode video-on-demand assets. So you store a high-quality mezzanine file in your Amazon S3 bucket. You use the AWS Elemental Media Convert API or management console in order to specify the video profile settings that you use for your video. This will create a job. The job will produce the outputs that you specify. Those will be written to your Amazon S3 bucket that you specify. The thing that this gives you is gives you access to codecs, formats, functionality broadcast features with a AWS interface. So if you're doing MXF, if you're trying to do a ProRes transcoding, if you're trying to do captions or advanced audio, ad signalings, or a bunch of the other ancillary data associated with a VOD asset, all of this is present with a simple AWS interface. AWS Elemental Media Live, this is a counterpart for live video, real-time video encoding. And really here what we've optimized for is reliability. Live video, you just can't go black. That's the, I think you heard Winston talking about this in terms of the Thursday Night Football. The ability to quickly, reliably deliver live video to your customers is paramount. So with AWS Elemental Media Live, what we've done is automatically provision resources across multiple availability zones. You think in terms of channels, so you'll provision a channel, and you can start and stop a channel using the APIs or using the management console. And behind the scenes, we're provisioning resources in multiple availability zones. We're monitoring those to make sure that the video is flowing successfully through them, and giving your customers a very reliable, robust experience. AWS Elemental Media Package, this is a service for live video packaging and origination. What we've done here is packaging, again, the panelists mentioned a bunch of the packaging formats that they try to support. This allows you to take one set of encodes, send it into media package, and we will do things like repackage it for other formats, but also add on-the-fly DRM if you specify it. We have a bunch of DVR-like functionality that we make available to you. So if you want to enable catch-up TV or startup TV experiences, or a 3-day, we have a 3-day content window, so you can say, hey, I want to allow my customers to go back in time up to 3 days on a live stream. You can configure that. All in a simple web services interface. AWS Elemental Media Store is video-optimized origin storage. So you can think of AWS Elemental Media Store as sitting between an encoder and a content delivery network. We'll talk about a use case later on where you push content into Media Store and then you use your CDN to deliver it. It's all optimized for low predictable latencies, which is important for keeping video experiences consistent. The last one is AWS Elemental Media Tailor. This is server-side ad insertion. If you think about the trade-offs that we used to have to make for ad-supported video, you had client-side ad insertion, which worked really well from a targeting perspective. So you could show each customer a unique ad that was specifically picked by an ad decisioning service for the particular viewer. However, because you were doing it on the client side, the user experience wasn't always great. There were often jarring experiences as video switched bit rates, switched encoding parameters, just didn't look smooth as it moved from content into ads and then ads back into content. On the other hand, server-side ad insertion worked great for delivering a seamless stream to your customers. Everything was encoded the same way, but you had to give up a bunch of the targeting. We built AWS Elemental Media Tailor in order to let customers avoid that choice. So we do the ad insertion on the server side. Each customer gets each viewer gets a unique manifest so that they can have unique ads selected by your ad decisioning service, but get that broadcast grade quality that is consistent for the viewer because you're doing it all on the server side. So all 5 of these products are available today. So you can go to the AWS Management Console and get started with them. They all have simple pay-as-you-use pricing models. So for AWS Media Convert, it's based on the content minute. Each minute of output that you select will have a price associated with it, so you only pay for what you actually use. AWS Elemental Media Live has a similar output minute-based pricing model. AWS Elemental Media Package has a gigabytes model. So we look at the gigabytes of content that gets ingested by the service and the gigabytes of content that gets originated and packaged by the service. So it's a volume of content that's similar for AWS Elemental Media Store. And then AWS Elemental Media Tailor works on a ad insertion basis. So there is a cost for every 1,000 ads that are inserted into your video stream. So moving on to the third part of the talk here today, why are customers choosing this? What have we heard from customers about why this is, what is the value proposition here? Really, it comes down to the same three things that I mentioned. Customers want solutions that are reliable, customers want solutions that are flexible, and customers want solutions that are allow them to focus, spend their time on what's important to their customers. So let's go through a couple of these examples. These are all customers who have been working with AWS Elemental Media Services in our beta programs. So the Pac-12 network is an example of a customer who, before I go into this, you'll see a couple of themes coming out here. The first theme is that different customers will use these services in different combinations. We very much built these as building blocks. They aren't a monolithic application where one size fits all. We recognize that that's just not realistic for video use cases. So what we've done is built these in a way that allow customers to organize them to meet the specifics of their use cases. The second is some of these, virtually all of these actually, will have components inserted into workflows that existed before Elemental Media Services were around. Some of those include ground workflows. So we'll talk here about a customer, Pac-12 Networks, who is interested in using Media Store as the origin for their content delivery networks. So on the right, you see their displayed devices. They're using CloudFront and third-party CDNs as a CDN in this example. Media Store would serve as the AWS Elemental Media Store would serve as the media optimized origination for those content delivery networks. They're using a ground-based encoder, so an AWS Elemental Live ground encoder that pushes video fragments up to Media Store. AWS Elemental Media Store then serves as the origin there, giving that consistent performance. They talk about focus and flexibility as the benefits there. So they say they're doing this to stay ahead of the technology requirements and keep our focus on the core capability of delivering great athletic experiences. That's the focus that I talked about there. Winston spent a lot of time on this, the Thursday Night Football example for Amazon Prime Video. Reliability is really the key thing here. As he talked about, they have this is a very high-profile event with a very unforgiving audience base. If people miss plays, if there's buffering, if customers don't get to experience what is happening on the field as it happens, they're not satisfied. Media Tailor, AWS Elemental Media Tailor, sits at a very important spot in the workflow. We are serving a unique manifest to every customer of Thursday Night Football. So they have built an architecture that really over-indexes on reliability so that they're sure to give customers a reliable stream. Cinépolis, for those of you who don't know, Cinépolis is it's one of the world's largest theater chains. They're looking at Elemental to help them be more flexible. So they have not just a chain of movie theaters, they also have an OTT brand called Click. And they're increasingly moving into live video, so not just VOD OTT experiences, but also live. And AWS Elemental Media Services is giving them flexibility in order to try new business models like live, and without giving up on what they call it resilience and quality, but it's really that reliability that we mentioned before. They also talk about focus here, so focus on innovating on new services. Fubo TV. Fubo TV is a sports broadcaster, and they're using AWS Elemental Media Tailor in order to test new monetization strategies. They talk about how that they can launch new services in a matter of minutes without worrying about the underlying infrastructure. So again, this is helping customers focus. This is helping them try new things, spend time on what matters for their business and not the undifferentiated heavy lifting of managing video infrastructure. And one last here, Quello. Quello is a technology platform that helps other video providers with contribution, encoding, and monetization. So they have a product called Stadium, I think Watch Stadium, for college sports. And they want to bring that broadcast quality experience to their products. They've been using Media Tailor, again, to do broadcast level ad insertion for OTT experiences. So they were very keen. We'd heard about frame accurate ad insertion. This was very important to them. They wanted to make sure that they could do that, and Media Tailor has given them a way to do that. So this allows them to focus on running campaigns. So they're make it easy for content programmers to get a new service running and focus on their ads. That's where they make money, as opposed to the undifferentiated heavy lifting of managing infrastructure. So hopefully with these examples, you'll see some themes. We really feel that these services will help you build video applications that are going to be more reliable, that are going to be more flexible, better adapt to the pace of change that is present in video, and let you focus on making your business special. Today was really a very quick overview. There's a lot of other sessions at the course of reInvent that we hope you check out. These will go into these services in more detail. Media Tailor and Media Convert are going to be on Wednesday. Thursday, there's a deeper, I think that session may have moved actually. Check your program. But more than anything else, try things out. These services are all available today. You can try them out in the management console, and we'd love to get your feedback. So thank you very much.